Hello learners, today we are going to discuss about basic statistics. So basic statistics is important for our syllabus in engineering and also for students reading in classes. So what is basic statistics? As we all know, the statistics are the aggregate of facts which are affected by a number of causes. By statistics we can represent a characteristics of a fact by the characteristics of a fact by some given data, and as we have seen, the basic statistics are represented by a table, and this table contains a group of data which represent the characteristics of a fact, and by evaluating the data. So basic statistics is a very huge chapter and is a very large chapter. So I am going to discuss the whole chapter and the important points in part video. So please keep informed. And today in basic statistics we are going to discuss about the table of basic statistics, variable, its frequency, group frequency distribution, cumulative frequency. This is the today's topic we are going to discuss, and this video will be in a very easy way, and in this video I am going to tell all the characteristics in a very easy manner that it is useful to understand the topics. First is the basic statistics. We already know the definition of the basic statistics. So let's know what is frequency. So frequency is nothing but that if a statistical data, let's say x, and data may be 10, it may be 20, it may be 30, 40 and 50. And what is frequency? Frequency means the occurring of the data, how many times the data are occurring in that basic statistics table. So if 10 is occurring 3 times, then its frequency will be 3, and 20 is occurring if 1 times, then its frequency will be 1, and if 13 is occurring 4 times, then its frequency will be 4. If 40 is occurring, let's say 2 times, and if 50 is occurring 1 time. So this is the frequency. That means 10 is repeating 3 times, 20 is repeating 1 times, 30 is repeating 4 times, 40 is repeating 2 times, and 50 is repeating 1 times. So this is all. This is the frequency. Frequency means the occurring of the data for how many times. That means repetition of the data in the table. Okay, so now discuss about what is grouped frequency distribution. Group frequency distribution is nothing but the range of data in a statistical table. That means let's take an example. If x, so this is simple frequency distribution. This is simple frequency distribution in basic statistics. Now for group frequency distribution, when there is a large number of data, let's take 10, 11, 12, 13, 14, 15, 16, and we are going through 100, 110, 120. So this is a huge amount of data present in this frequency table. So if we try to evaluate this amount of data, then the equation or the complexity of the evaluating of the equation will be very much complex. So for this we will make the data in a range, and this huge data make the calculation more complex. So we try to group this amount of data. Like if we take 10 to 20 is a given data range, then 20 to 30 is a given data range, 30 to 40 is a given data range, 40 to 50 is a given data range, and so on. And we are getting, let's take, that is 110 to 120. So this is we can group this amount of data and thus reducing the complexity of the calculation. So this is known as grouped frequency distribution. This is known as grouped frequency distribution. Now what are the terms associated with this group frequency distribution? Now we all know that this is the simple frequency distribution. When there will be a simple state of data, only single data will be available, this will be simple frequency distribution. And for group frequency distribution there will be a range of data, there is certain range will be there for group frequency distribution. And what are the terms associated with this group frequency of distribution? There is the term that is class interval. Class intervals means, class intervals is nothing but that is what are the interval present between, that is how many datas are present between it. 10 to 20, how many datas are present? There is total of 11 datas present. Okay, for 20 to 30 there is always, and there is also 11 datas present. What is class limit? Now class limit, next important in grouped frequency, that is the class limit. Class limit is of two types. Class limit, first is the UCB and second is the LCB. And in before UCB and LCB, let's take what is UCL and what is LCL. UCL is nothing but upper class limit, okay, and LCL is the lower class limit. LCL is the lower class limit. So if we take a distribution, so if we take this type of distribution, when where x is the marks of 10, that is 0 to 10, 11 to 21, 21 to 32, this is an example of group frequency distribution, and this is the frequency of the respective groups. Okay, so what is LCL? LCL, as I said, that is the lower class limit. That so the lower class limit, if we take this class 11 to 21, then 11 will be its lower class limit, that will be LCL, and if we subtract it with 11 minus 0.5, this will be its LCB, that means lower class boundary. So lower class boundary, it has the formula that LCB is equal to LCL of the class minus D by 2. What is D? D in this case, the difference. D is what? D is the difference between the numbers or the datas present in a certain class. That means 11 to 21, 11, then 12, then 13, then 14. So what is the difference? 11 to 12, that there is the difference between 11 to 12 is 1. So here D will be is equal to 1, and lower class limit is what? As I said, lower class limit is the LCL, that is 11. 11 minus half, that will be is equal to 10.5. You don't need to remember this formula, just remember that if a class contains the lower class limit value, then its lower class boundary value will be 0.5 subtraction of that value, that is 10.5. and if we take UCB, then its upper class limit, that is 21, is called the upper class limit, and if we add 0.5 with this upper class limit, then it will be its UCB, that means upper class boundary. So upper class limit is the maximum value of a certain class, and if we add 0.5 with that maximum value, then we will get the UCB, that is the upper class boundary. And mind it, this 0.5 is applicable whenever there is a difference of 1 between a certain class, that is 11 to 12, 12 to 13, 13 to 14, we are getting 0.5. But if there is the difference 11 to 14, then there is the difference will be 2. So LCL of the class minus 2 by 2, then this case D by 2 will be 1. Okay, so this is the lower class boundary and this is the upper class boundary. Okay, and this is the lower class limit, and this is the upper class limit. For these classes also, this is lower class limit. Mind it, this is lower class limit. Limit means the maximum value and the minimum value of a certain class. Okay, there, that means 44 has the, here is the lower class limit and 54 is the upper class limit. And if we subtract 0.5 from this, that is 44 minus 0.5, then it will be is equal to 43.5. this will be is equal to LCB, and if we add 0.5 with it, then it will be, it's UCB. Mind it, UCB. So I think this is clear to you. Now there is another term, and the term is class mark. The term is class mark or mid value. So mid value is nothing but the middle value of a certain class. That means if we take this class 22 and 32, then its mid value will be 22 plus 32 by 2, and this will be how much? That is 54 by 2. That means it will be is equal to 27.5. Okay, this will be the mid value of that class, that is 27.5. okay, so this is the class mark or the middle value. So mind that term, that is class mark. So a question may come that what is the class mark of a certain statistical data or a certain group. Then you may confuse, what is class mark? I didn't read it. So class mark is the another term which is actually the mid value of a certain class. Okay, and width of the class, as you already know, that is, or remind it, that is width of the class, width of the certain class is equal to UCB minus LCB. So for this class, if we take for this class, so what is its UCB will be 21.5, that means adding 0.5 to it, and its LCB subtracting 0.5 from it, that is 10.5. so what is the value? The value is 11. Okay, so this is the width of the class. This is the width of the certain class. Okay, now moving to the cumulative frequency. Now comes the cumulative frequency. So cumulative frequency is what? That is, for a simple frequency distribution, we need the total observation, that is total frequency observation, lesser or equal to an observation. If the total frequency observation is lesser, then it will be called as less than type of cumulative frequency distribution, and if it is greater, then it will be called as greater than type of frequency distribution. Okay, so for cumulative frequency there is two type of frequency distribution, that is less than type. This is a very simple, and greater than type. I will gonna give it example. So less than type of cumulative frequency is mostly used. So less than type, let's take a frequency or statistical, let's take a statistical data. Let's take here 2, 4, 9, 11, 3, 6, 4, 1. So in this case, if we say that what is the less than type of cumulative frequency of class 9, then it's, if the frequency of class 9 is 4, then the previous frequency of 4, that is 4, 6, 3, add these three things, 3 plus 6 plus 4, that is 13. This is the less than type frequency of class 9. If we say the less than type cumulative frequency of class 11, then we need to add 1 with the previous frequencies available, 1 plus 4 plus 6 plus 3, and the sum will be the less than type of cumulative frequency of class 11. And if we say what is the greater than type of frequency distribution of class 6, then we need to add the successive frequencies from that class frequency and add all of them. For class 4, the greater than type of frequency will be 6 plus 4 plus 1, that will be 11. So this is the greater than type of cumulative frequency of class 4, or you can say not the class, this is, you can say data, and this is obviously a data, or x is equal to 4, and for x is equal to 9, the less than type of cumulative frequency is 13. So if we clear the concept that for less than type, we see what is the frequency of that corresponding class, and then we will add all the datas previous, or we will add all the frequencies previous to that frequencies. And if we say greater, what is greater than type of cumulative frequency for a certain class, if we take a certain class, then the greater than type of frequency will be the frequency, that is the sum of frequencies previous to the corresponding class plus the frequency of that class. So if we say what is the cumulative or greater than type cumulative frequency of class 11, there is only the frequency of that class, that is 1, and there is no other successive frequencies. So the greater than type of frequency will be itself its frequency, that is 1. And if we say less than type, then it will be 1 plus 4 plus 6 plus 3. So this is as simple as that. I think it is clear to you. If this helps you, please like and subscribe.